From the John Martinson 4D Experience Lab at Purdue University, I'm Mercer Applin with the Fusion Studio for Entertainment and Engineering. Welcome to First Fridays at Fusion Studio. Today we are joined by Scott Pfeiffer, an accomplished architectural acoustician with more than 3 decades of experience designing and evaluating listening spaces from performance venues to complex audio-video environments. A fellow of the Acoustical Society of America, Scott brings a blend of physics, music, and human perception to his work, exploring how shared listening experience shaped the design of spaces from the campfire to the concert hall. Scott, welcome.
Thanks, Mercer. It's good to be here.
Yeah, delighted to have you. And folks, if you have any questions for Scott along the way, don't hesitate to throw those in the Q&A section. I'll be keeping an eye on that over the course of the next hour, and we'll try and feather your questions in where they make the most sense. So if I don't get to them immediately, I'm not intentionally ignoring you. I'm just trying to find the right place to squeeze your question in. So, Scott, I think we wanted to start the content today with a quick discussion of our human hearing system and where we came from. Take it away.
Sure. I've shared my screen just to use a couple of images to set the context. Acoustics can be thought of as a very mysterious discipline, and a lot of people wonder about the alchemy that's behind what we do, and ultimately we do our best to make it something that is rather accessible. And to do that, we think back to where our hearing comes from, where we evolved to hear, the environments that we were in the early days while our hearing was being developed. And they were complex environments, whether it was a forest or other landscapes. The world around us was varied and intensely variable. Background noise had a real meaning for us. If you listened for a creek to find a water source, or you heard a twig snap behind you, those were the things that would help you navigate your environment in a way that was hopefully safe. And that snapping twig had a real meaning. Let me just figure out how to activate the next slide. And so, we got very good at directional hearing, and we got very good at finding our way through the world. Can you just tell me are you still seeing a forest?
I'm seeing forest. Yep.
Oh, okay. Not the next slide. Figure out why that is. There we go. So that knowing which direction that snapping twig came from was really important to us. And so our hearing evolved to be very accurate in the terrestrial plane, down to a degree of directional hearing capability. And of course, if we keep our ear pods out, we can still use these navigational tools in the world where we navigate today. They still serve us in the environments that we surround ourselves with. And so these things become really important, and then we insert ourselves into environments where we want to actually communicate with each other. And ultimately, for us, the campfire represents probably the simplest form of gathering and communicating with one another that we can imagine. And as a former Boy Scout leader, I found myself in these settings a lot. Some of the amazing components of this are that, ultimately, you have everyone's attention. You can be easily heard by everyone around the circle. Everyone can hear each other well. That means if you get to a good part of the story and you generate some laughter, that everyone hears each other as well in that response, and it becomes an easy place to both receive and respond to the messages that are shared around the campfire. And if you get quiet, the quiet sounds can still be heard. And if you get loud for some reason, that also translates to a change in the emotional content that you're delivering, and that's really valuable to the people around the fire. And so, as we start to enclose people into environments, there in the current day, we think of this as biophilic design inspired by the wonder of nature. In the long ago days, columns and arches might be represented in order to feel as if you're in a canopy of trees. Um, Sometimes the connection becomes intentionally quite literal, as with the Farnsworth House, which was in the mid-century modern era, and the idea was to really connect us to nature. And so, of course, it's a seamless connection. The floor continues from the inside to the outside. The visual connection to nature is rather profound. What they sometimes overlooked in this era was that the acoustic environment you placed yourself in was the furthest thing from natural that could possibly be. Straight, flat surfaces, all glass, drywall, stone, all made it very difficult to communicate in a space like this. It gets very loud very quickly. And so as we work through design of buildings, we're trying to identify the ways in which we can make buildings sound more like the spaces that we were evolved to hear in. Um, One of the things that we've sometimes done difficult to do in a virtual setting is introduce background noise to a room where we're presenting. And if we start with a low level of background noise in the room and we talk about this point in the presentation and then turn the noise off, you can watch the whole audience and their shoulders drop a little bit and they relax back into their seats. For us, that's a demonstration of the fact that when we can't hear everything in our surrounding, when that noise is present, we're assuming that we're missing something, that there's a sound lost in the noise floor that might be dangerous to us or that might cause us some challenges. And so even that, something as simple as a small amount of background noise has a physiological effect on us and limits our ability to really fully engage in the way that we might in that setting around a campfire. And so for us, especially in the design of performing arts venues, we're always trying to think about how do we create the environment extrapolated to a large number of people that replicates that sense of connection with the performer on stage and that removes background noise as a distraction, delivers energy that is coming from all around them with the right amount of directional realism so they know where the sound came from, so that the changes in the dynamic are meaningful and bring people along for the emotional ride. And if we can do that scaled up to the size of an audience, then we've really found our way to be successful. And so with that as a foundation, I thought I would give it back to you, Mercer, to figure out where you want to take the conversation from here, and I'll stop sharing.
Yeah. You come from a physics background. How did studying physics while staying close to music and music making shape the way that you communicate with technical and non-technical collaborators?
Well, physicists are notoriously bad drawers, sketchers. We draw stick figures and motionless or weightless springs and frictionless ramps. But sometimes it's in that effort to communicate a really complex topic in a very simple way. The whole purpose of physics and physics labs, especially, were to take a complex phenomenon and make it simple, boil it down to the essence of what are the things in control over the outcome of this experiment, limit them to just the minimum number of variables so that you could know what was happening. And in the same way, when you come into a complex problem like a room that's not behaving the way you wish, identifying as quickly as you can or as readily as you can the control variables that are present becomes a really meaningful thing. And then being able to communicate that to people who are not versed in physics or in acoustics in the simplest terms possible is a really important aspect. So I take inspiration from physics greats like Richard Feynman, who was one of the best physics educators in the history of the world that I'm aware of. So if you haven't come across any of his books, any one of them is worth a read. The most readily accessible one is probably Surely You're Joking, Mr. Feynman, where he outlines a number of stories about delivering really complex answers to difficult questions in a very easy and accessible way.
That's great.
Yeah.
In the course of the projects that you work on, you and your collaborators have the ability and the impetus to change the way rooms sound pretty significantly.
Mhm.
In renovations of existing and beloved venues, how do you protect what people love while addressing the problems at hand?
That's a really good question. I was invited to work on a project at the Hill Auditorium at University of Michigan, which fits this category exactly. It's a very strange room, and maybe I'll share again if I can do it quickly and thoughtfully. Um, get to the right image. Um, it is the whole room is a rotated paraboloid. So the ceiling becomes the wall again, and it's all in the shape of a parabola. And the acoustician's idea when it was built in 1903 or 1913 was that a single person could speak to 4,000 people without the aid of a microphone, because microphones and loudspeakers were not readily available at the time, and it worked beautifully. You could absolutely the room itself is an architectural amplifier. Um, from an acoustics perspective, especially as an acoustics nerd, you go into the room and you go, this is terrible. The focuses are all over the place, and so the if you're listening to a violin um, from deep in the section, you hear them pop out of the orchestra in a way that's not ideal based on where you're sitting, because that focus treats each position on stage differently. And so it's easy to get very critical and say, here's all the list of things that are wrong with the room. But when we went to renovate it, it was very clear that they did not want to lose what is special about Hill Auditorium. Um, and ultimately, what we realized after interrogating the circumstances for a bit was the same parabola works in reverse. So performers would come from all over the world to perform on this stage. Luckily, the paraboloid works really well for soloists. So if you stand in the soloist position, it sounds great to you. You sound great to the audience. And when 4,000 people clap for you, it sounds like 16,000 people because their energy has been focused. So artists who are acoustic artists that don't typically play in venues that large, not even this large, often don't play to houses that are this big to start with. We're just being levitated off the stage by the appreciation of the audience. And so recognizing that our job was not to make a perfect acoustic experience um, in this room, but to preserve this special opportunity for the people of Ann Arbor, Michigan, a relatively small Midwest city, give them access to the greatest artists in the world who just begged to come back time and again, because of the experience they had while they were here. Really reset for me what the values that we bring to the building are. Um, in the process of I put together a talk for the 100th anniversary of Hill Auditorium, um, and realized that Tony Bennett or did when he was living, goes around the country and would perform, and he would always come to a point in the performance where he would lay down the microphone and a song and say, you here in insert your town here have the most fantastic venue that I've ever had the pleasure of performing in, and I want to show you how wonderful this venue is by doing this next tune a cappella. And he would sing "Fly Me to the Moon" because it was in a place in his voice where he could really project well. Um, the audience would rave about it, and the newspapers would write about it as we have a one of a kind venue here in our town X. And it was something that helped me realize again that we're not designing for perfect acoustics. We are designing for a community to participate in the creation of civic pride, to and that's what Tony Bennett was tapping into. Was every town was very proud of their home venue, and he gave that back to them, gave them the respect of acknowledging the quality of that space. And so again, for me, that has had a profound effect at helping me recognize that while our role is to make really good acoustics happen, it's not always uh, perfection is not the thing. We need to acknowledge what is loved, what is special, and ultimately, even in a new building,
Mm.
create something that couldn't be everywhere else, that really belongs in the community that we're building for, so that they can go away with a real sense of place that aligns with their values and their hometown. So it's incumbent on us to be thoughtful about that and not chase uh, the acoustic holy grail.
Right. Similar to, the fact that an entire community is involved in consuming the art and consuming the performances that take place in these venues, there's a wide community typically involved in the team of people putting together a building or a renovation project, right? Ranging from an architectural design team through end users who will eventually inhabit that space to, the person who carries the checkbook. Are there ways of kind of aligning all of their kind of expectations through simulation and through kind of managing how they envision the space they're about to inhabit?
Yeah, there are. First and foremost, anyone who has any role in a building or a production or anything that you work to create, um, it rarely gets created alone.
Mhm.
And so for me, the first job is to make this a process of lifelong learning. I need to know, over the course of my career, it's great if I can be good at acoustics, but it's even better if I can learn from each structural engineer that sits across the table from me about how they approach the problems they have to solve, as with the mechanical engineer and the fundraiser who has to raise the money and bring the checkbook to the table. Um, the better I understand their job, the more effective I can be at shaping the recommendations and the direction I help steer from my corner of the project to a better outcome.
Mhm.
Um, so that's one part. The other part of it is really around making acoustics as accessible as the judgments that we all make about the world we inhabit. So we use a tool, an oralization tool, where we have a space in our office. Again, I'll share again, that allows us to demonstrate acoustics. What have I shared? I have no idea what I shared. Let me unshare. Try that again. Yeah, we can demonstrate through a 22 channel surround setup, the behavior of sound and the choices. More importantly than just the behavior of sound in a room we're designing, we can demonstrate the choices that we make together on the way to the design. So now I can fix this correctly. Um, so we can gather about a dozen people into a room, put them in a chair that is a theater chair, allow them to look at a rendering of the status of the room under design, and listen to the choices we have to make. How tall does this building need to be? Um, if we make it 10 feet taller, how does the sound change, and is it good or bad? Do you like it better or worse? Um, the if that decision is about reverberation time and earlier reflections and words and phrases and graphs and charts that are very difficult for people to understand, that can be really challenging. We did a model for a project at the National Art Center in Ottawa where we substantially needed to. It was a renovation project. We needed to change the way reflections behaved off the side walls. It was architecturally challenging to do within the context of the story for them, and we modeled it and made it beautiful, and we found a way to solve it. And I said to the client, look, we're really excited, we got this solved. And they said, God, I'm really excited that you're excited, but I don't understand the lines on the page that you're sharing with me right now.
Right.
And oh, right. Okay. Well, let me back up a little bit. In a setting like this, what we can do is say, here's your existing room. Here's your existing room with the walls moved where we want to move them. And you can listen to them and hear the change. You don't need any of that language or any of that training to follow that. You either like the change better or worse. And you can react to it as easily as going to the eye doctor when they say, do you prefer A or B? And if
Hmm.
we can get it down to that point, then we can discuss all the technical things that go behind the decisions we make together and the costs and the steps we'll take to do it. But we can do that where you've already heard the change in a way that you understand, where you are ready to participate with us in enacting that outcome because you have a emotional sense of what the value that it brings with it might be. So,
We have a related question in the chat.
okay.
David Schwind asks, I assume
Hi, David.
22 channels of in your listening environment are output channels. I'm curious how many input channels you have available for room simulation.
Sure. So the way that works is we model the room either in Odeon or treble, um, and we're using a second order ambisonic technique, which is not so much input channels, but directivity of energy as it um, arrives at the listener. And so we map that directivity of the received energy to the um, place you're sitting in the special chair, and you get that input. To some degree, I could answer it another way. Um, each of the sources we're playing, each of the sounds that we play through this, were recorded in an anechoic chamber, so that the sound of the musician performing is absent of any room wrapped around them. Each performer records their part. We have quartets recorded. We have, in this case, what you see on the screen is a soloist singing with a piano. But each performer on stage is represented by 5 recorded channels, one that's from overhead, one that's from in front of them, one left and right, and one behind. What that does for us is when we put those 5 channel sources into the model, we're activating the energy that comes from the performer to the upstage wall is the sound that left the back of the performer, as recorded by the microphones behind them. And so we're maintaining the directional realism and the sense of directivity of the instrument itself as we place it onto the stage. And so in that sense, a quartet involves 20 input channels of source material playing into the model that then get accumulated into the 22 to the ambisonic results that then get mapped to the 22 channels that are in the space itself. Did that answer the question sufficiently?
I think so. David, let us know if you have a follow-up. Can you describe or think of a moment when that oralization process changed minds or yielded a potentially surprising result from
Yeah.
the congregation assembled?
Well, I'll tell you about the first failure we had first. We invited the faculty of Rice University to come while we were designing their opera house, and we worked on models, got them behaving correctly. We used canned recordings of anechoic content because we didn't have any of our own. And as beautifully as we had rendered the possibilities for the design of the opera house, none of them could hear the room. They could only hear the performance, which they felt was subpar. And so the the singer in that case was too distracting to allow us to make any of the decisions that we wanted to make together. So we said, okay, thanks everybody for making the trip. Let's do other things we have to accomplish at this phase in the project, and let's reconvene in a few months, and we'll try this again at our next decision point. And that's when we went to hiring musicians that we knew that were of high quality, taking them to Northwestern University where they have a anechoic chamber and recording them that way. Um, Once we got the content improved, one of the surprising results really was the same group of people coming back, listening to the options. We had the great fortune of touring Europe with them to see various opera houses, and they had narrowed down their inspirational guidance for the project to either the Estates Theater in Prague, which you would have seen if you've seen the movie Amadeus. It's an old movie, but maybe in the music community, there's people who know about it. It's the theater where Don Giovanni was composed and performed for the first time. And the other option was the Royal Opera at Versailles, the Palace of Versailles. two rooms are quite different. We were able to model the behavior of them and model rooms and new designs inspired by those models. Um, having we had good progress sharing the results from the models, but the university architect was getting frustrated, and we could tell he was getting frustrated. And we stopped the process a bit and said, David, what's going on? You don't seem like you're with us on this. What's happening? He said, well, you're all talking about these differences you hear, and I can't hear them. And at that moment, the director of the opera program said, "Oh, David, let me tell you, the States Theater is the two theaters behave very differently. The operatic voice is made up of two parts. One is the head voice, and it's not very pretty." And he demonstrates and he goes, "Oh," and he sings with very nasally note and says, "That's how you get to the back row. That's where the power comes from." And a beautiful sound comes from combining the head voice with the chest voice. And he sings a lovely tone, which I won't try to do for you. Um, and he says, "The States is all about the head voice.
Mm.
It's a room with the balconies stacked one right on top of the other. It's very frontal. It's about hearing clearly, and you get good representation of the original sound that came from the singer. The Versailles is all about the beauty of the chest voice. The room embraces the singer and gives its energy to you, and you can hear it in a much warmer way, in a much more beautiful way. And suddenly David says, "Oh, I get it." And we listen to more, and
Mm.
he hears what he's supposed to be listening for. The reason I share that story is because ultimately we didn't have to sell anything. We didn't have to
Right.
convince anybody. We provided the tool to the client who talked to each other within, saying they're on the client side. And they just, because this tool was available, they were able to talk to each other in a way that allowed them to come together and make a decision and feel like they were on the same page. And so
Mhm.
I think that setting is really important to this process.
How early in the process do you typically introduce the concept of oralization and potentially bring people into your office to experience it?
It can be used throughout the project. In the case that I just described, it was very early. We hadn't even decided on the fundamental form of the room yet. We knew it was going to be 600 seats. We knew it was going to be an opera house, but the choices of where to place those 600 seats and how to enclose them in a volume had not even been made yet. So the models were necessarily very crude they were different in their geometric form, but they were crude in their detailing. Um,
Hmm.
what you see on the screen here is Brown University's, which I know you're familiar with, but for the audience, Brown University's concert and recital hall. And it's intentionally rendered in this white model fashion, partially to say, hey, we're not done yet. This is,
Hmm.
the level of refinement in the model is the level of the refinement in the acoustic characteristic that you're hearing about the model. So it's accurate to the sense of scale and size and intimacy, but this is not the room you're going to hear when we finish the work. The
Mm.
further along we get in the process, the more detailed or the more accurate the acoustic model can become to what you ultimately get. But there are still approximations. We're still not at the point of modeling the wave equation throughout the building. We're making decisions about how the models are treated that are simplifications that remain audible as simplifications even when the building's finished. In terms of we know all the answers, but we can't model them so accurately that it is the room you will hear. Um, but the important part is understanding that we're modeling it well enough that if we have a decision to make, the difference between A and B is proportionally accurate, so that we can use it to make
Mm.
those kind of decisions.
Yeah, I have a question, and that's kind of tangentially related to another one that we have from David in the chat.
Hmm.
Um, how how do you convey to the audience of people listening to the oralization, the level of, I guess, fuzziness, the level of blurred
Hmm.
lines versus this is what you're going to hear.
Sure.
And to tie in David's question, he asks, I imagine you have compared your simulation to the subsequently built rooms. Can you comment on any differences?
Sure. So one thing we do to start with the question of how do we set the context for how much of this is believable, how much of this is what how do we communicate the fuzziness of it? Um, One is that in many cases we can model a room that people in the room are familiar with, whether
Mm,
that's choosing a nationally known concert hall like Boston Symphony Hall or Carnegie Hall, or if it's another room on campus for an organization that if we're working for a campus organization. And we can model that space, that comparable space to say, is this model that you're listening to plausibly the same room that you hear on your campus? And the answer typically is yes. What you're hearing is geometric representations that are catching features of the room that that are defining features that make the room sound like the room. It doesn't mean that you would be fooled and think that somebody transported you into that space, but the features are identifiable enough that you can say, yes, that's the right room. Then when
mm,
you take them to a new room that doesn't exist, there's a level of confidence that, oh, if you could model the existing room that closely, I can believe that this new room is the room. Certainly in a renovation project, that's straightforward. We can model the room
right.
we're going to renovate, and then we can make changes to that room in the model, and you can say, oh, we either moved them in the right direction or we moved them in the wrong direction, and that's sometimes enough to say those changes are making a difference that I can hear. They're audible, and I appreciate that difference, and I want that in my room. Um, to the question of listening to the room after we're finished, the Rice Opera is another. Back to the Rice Opera House. It's been built now for 5 years. I've both sat in the seats on the sidearm under the very thoughtfully shaped overhang that's above your head, that's intended to distribute sound to you in a way that is not distracting, doesn't draw your attention to the fact that it's coming from overhead, but that architecturally reinforces the sound from the stage. And I can both in the model here in the room in Chicago and in Houston, I can find the characteristics of that seat in real life and in the room in a very believable way. Um, it was part of what helped us make the decisions about how we shaped that surface over your head. And in the end, those sounds really exist in real life because of the shaping choices we made. Um, and I chose a very specific one. Overall, the room sounds like the room wherever you sit.
Mhm.
The model here sounds like um, the room sounds better in real life. Um, but the two are recognizable as the same characteristic.
That's great. We've got another question from Richard Rainville who asks, what's your opinion of using technology instead of room design to solve for acoustics of a space? Thinking of Dizzy's Club at Jazz at Lincoln Center, which
Sure.
features an immense glass wall and a lot of tech to make it still sound like an intimate space.
Yeah. So I've certainly worked with enhancement systems as a technique for solving acoustic problems when the architecture can't be modified or can't be sufficiently modified to make a good result. Um, Also, again, back to the Hill Auditorium example, um, uh, that window onto the Columbus Circle for the Jazz at Lincoln Center space is a huge component of why that room is so popular and successful. So sometimes acoustics doesn't take the first need. Um, Creating a space that is incredibly dynamic, connected to the city that it's in, and provides you an experience that you could not have anywhere else is equally as important as the acoustics of the room being particularly special. The acoustics
Mm.
have to be good. We have to be able to enjoy the performance. It can't be one or the other. We have to do both. Um, and I think in that case, you make choices about what's possible. Now, that glass wall is tilted away from the stage, so it's not straight vertical, and that helps to send the energy up into the ceiling that has additional diffusive shaping. So they took care of the problematic aspects of the acoustic behavior of the room in the design of the acoustics of the space, and then inserted some of the qualities you want to have that they couldn't provide with natural acoustics in that shape of a room with the electronics. And I think that that balance becomes really important. It's pretty difficult to overcome a problem in a room or an echo or um, a particular coloration that comes from flutter or any of those kinds of things cannot be removed by electronics. Um, so we have to get some of the basics right, and then we can use the tools, the electronic tools, um, to extend the range of what's possible within a space.
Hmm.
Um, so I think they have their place, and we are users of those tools. And but again, I think maybe calling back to my physics roots, I go back to, there are a number of those products out in the world. The most well known is probably Constellation. There's the successor to the Lares system, which is now Acoustics. There is a European company, Acoustic Control Systems. There's another European company called Amadeus. Um, each of them has tools within their toolkit that make them more or less appropriate to solve a given problem you might have in a room. And for me, I go back and look at what were the fundamentals, what was the philosophy behind the electronic system design, and how does that relate to the problem I'm trying to solve. Um, I have a whole hour-long presentation available for that one that we could do another time. But I think it's really important to go back and ask yourself, what was this tool created for? What are its philosophical and its mathematical underpinnings, and how does that relate to the problem I'm trying to solve in the room?
Yeah, that's fascinating. And I mean, it seems like a lot of the ability to use electroacoustic enhancement systems and the modeling and oralization tools that you've described um, may not have been available, especially in their current level of development
Hmm.
early in your career. Um,
True.
is there a lesson from your early professional years, either with measurements, modeling, listening, that you still use on a regular basis, even amongst all of the fancy new tools?
Yeah, I think so. I mean, staying with the enhancement for a moment, my partner Carl and I worked together on a renovation of Royal Festival Hall in London,
Mm,
while we were at our former firm. And that was one of the first implementations of an enhanced space. It was called the Aero system, and it had Helmholtz resonators in the ceiling that had microphones stuck in them. And the idea was if you separated them all by a couple of hertz, they would get excited by the sound on stage. They would ring, but not with a lot of energy. But you could take that energy into a microphone and you could play it back through loudspeakers, and you could lengthen the reverberation time with that tool. Um, it had a panic button because it would occasionally go into feedback that would be tremendously horrible. So you had to be ready to. There was a guy who sat in a booth and listened out for the woo, and he would have to hit the panic button. Um, but you know, recognizing that the tools are not always ready for prime time, um, and that ultimately, whether it's a design tool or an implementation tool, an implemented result like that. Um, there are early days of all the design tools, and again, if you focus on, now I feel like I'm repeating myself, but if you focus on the fundamentals that lead to the creation of the tool, you know what its limitations are.
right.
In physics, every equation has a set of assumptions. So, Newtonian physics wasn't wrong when Einstein came along. They just said, well, wait, what if we go outside of the assumptions that you're living with, And um, so as long as we recognize, as we adopt new tools and adopt new techniques and new technologies, that each of them has their own limitations, and we're thoughtful about them, that becomes really important to the end
Mm,
result. And I think to that degree, uh, limitations have, is where creativity happens, right?
right.
You, if you could just do it all, it would be way too easy, and we wouldn't come up with any creative results.
I want
So,
to dig into that a little
okay, that
further.
sounds great. Yeah.
What's an example of a project constraint that looked impossible at the time, but became solvable through,
Mm.
thinking and iteration and
Oh, that's fascinating.
perspectives?
Oh, um, hmm. Um, I think the National Art Center in Ottawa um, was a room um, where the shape of the room, it's a glass multi-tiered opera house looking space where all the sidewalls and rear wall are glass, um, which is not an ideal acoustic material for that
Right.
purpose. Not at that quantity. We can do things with glass to make it better. We can curve it. We can make it stiffer and heavier. Um, in that setting, it was not the right surface throughout. Um, Ultimately, that was, the place where we found a solution that was completely unrealistic from an architectural point of view. Would have fundamentally changed the things they love about that room, that when the lights go up, it glows from the outside and you know a thing's happening. Um, and when the lights go down, the walls disappear into darkness, and that's somewhat magical too. Um,
Mm.
and so, ultimately the answer was we're not going to solve it architecturally. We're going to lean on another tool, and that tool was electronic enhancement in combination with a really, 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 really good orchestra shell to make the room work for orchestra. Um, because there's a portion of that, the heavy lifting of making an orchestra sound great that the electronic systems have not accomplished yet, in my mind. While there are electronic orchestra shells, they don't double the power of the ensemble the way that a good
Right.
physical enclosure can. And so combining, recognizing that there were limitations to the architecture that could not be overcome, and there was a tool in the world that involved microphones and loudspeakers that could simulate an architecture that you wish you had, was probably the closest thing I can grab. That it felt impossible at the start, but we found our way through.
Yeah, gotcha. That's awesome. Are there still unanswered questions or room for research and exploration in the field of acoustics, or have all the stones already been turned over?
No, there's lots of room. You know, Not only does our expectation for what a great, you know, we want to gather a bunch of people in a room and share an experience. That's what we're after. Whether that's performing classical music of centuries ago or modern compositions of today or instrumentation that is, you know, a person and a guitar or whether it's a whole ensemble, we want we want to create a room that connects those people together. Um, our expectations for what that connection requires to sound right change all the time.
Hmm.
Um, Fundamentally, there's some things about that connection that are established. We understand something about how the ear works. We know that architectural amplification happens in the first 50 milliseconds, give or take. You can stretch that out a little bit if you have good energy earlier, and you can make useful reflections arrive all the way up to 80 milliseconds. Um, we know that reverberation can enhance the sense of envelopment that you have and the connection you get from that artist, but it can also distract from it depending on how rhythmic the content is. So some of those things are immutable in the fact that the change in the music style will require a different outcome, but they don't change the physics and they don't change our hearing apparatus.
Right.
So um, so those things there's a settled component of that and there's a wide open component of that. And I think exploring where we are as a culture and landing in the right spot as often as possible and recognizing those changes as they're occurring is the ongoing job of solving these challenges in rooms.
Awesome. Is there something that you or other members of an audience immediately recognize or can immediately recognize or notice about a new venue or an existing venue that perhaps an architectural design team underestimates?
Yeah, I think there's lots of those. Um, I think there's a tendency, um, you know, it's a tough challenge because creating new things is really important. Taking risks is really important. We don't progress if we don't take some risks. But there are times um, when the risk is taken for risk's sake, to do
Mm,
something innovative for innovation's sake. And I think that there is a tendency to want to innovate without recognizing what you're innovating from.
right.
And so a lot of times if we get involved in a project with someone who's never done a theater building before, they want to just start from blank paper and go, well, why don't we put people, up here instead of, where they're always sitting, in these other rooms. And and we should embrace a component of that because really interesting things happen when you break some of those rules. But there's a need to restrain some of that, or find the balance that recognizes the lessons we've learned over hundreds of years of gathering people around a stage, whether it's or a courtyard. When you do a performance and people start to show up, there's a natural way that, you know, in the first ring, everyone will just encircle you on, in 160, 180 degrees. Once you need to go a couple of rows back, they gravitate towards deeper in the middle of the crowd and thinner as you get around to the sides because there's a sense that you want to connect eye to eye with the presenter and they're mostly looking straight out to the audience. And so, you know, innovating but recognizing that there's a natural way that people want to interact is the necessary component to say, is this innovation a good idea or not? Does it align with the art?
Yeah.
I guess is really the fundamental component. Does it align with the art? And for us, we're creating these containers for the art. And if we don't start with the art as the guide, I think you can make some really silly mistakes and create buildings that are not that interesting, even if they look like they were on paper.
When you are kind of considering a new idea or
Mhm.
something that isn't often done in room design or in architectural acoustics, how do you encourage those teams to make decisions and wise decisions with uncertainty?
Well, I think having as much of a shared experience as you can have. So
Mhm.
whether you attend shows together, whether you gather a bunch of material of similar or varied rooms and get them on a wall so that you can say, well, the thing you're suggesting shares an element of this thing that was done over here. Let's talk about how that worked out. And so that it's not to say you can only do what's been done before, but it's to say, let's measure this idea against the closest comparators we have in the world so that we can avoid making a mistake that might have already been made. We have this incredible laboratory of thousands of rooms that have been built around the world, even those that are gone, but we know have the record of them. And we have some sense of which ones were most successful and which ones were less so. Um, and there's something in there always to be learned from that, and to do to skip that step. You know, if you're in
Right.
academic world, you would never do a paper without doing a literature search first. So, why would we start a drawing without investigating the built record before we got started?
Another question from the audience. One
Sure.
of the arbiters of audience opinion is that it may be shaped by publicity and press reviews.
Mhm.
Can you comment on this?
Sure. One of the most fascinating things that happens um, in performing arts is the um, the creation of lore that has nothing to do with the truth. You know? We did a building here in Chicago that the story that gets told every time they give a tour is that Jeannie Gang invented the ducts, the fabric ducts that deliver air to the room. She didn't invent the fabric ducts. She doesn't claim that she invented the fabric ducts, but someone came up with this idea that I'd never seen those before, and now they're in this room that was designed by Jeannie Gang. They must have been her invention. It's just not true. Carnegie Hall, famously had a renovation that was very unpopular in the critical eye, and ultimately got blamed on found concrete under the floorboards of the stage that someone said caused the acoustics not to be very good. But that had nothing to do, you know, in the pre-renovation, there was a big hole in the ceiling where they used to raise and lower stuff scenically, and they closed it up, and it was on a curved surface. And it made it very difficult to play on stage because the focus back to the performers was very late and very distracting. But no one wanted to admit that, so they went ahead and went with oh, we found concrete under the stage and now we fixed it because um so so I think, as with all miscommunication that occurs in the public realm, the best we can do is recognize when the critique in the world is from a bad performance, or problems with the systems that supported the performance that day, or and look for the things that are a result of the design of the room itself, and be sure to keep those separate, and to try our best not to react to every negative review, um, but to also listen to them all in case they share a commonality that we need to respond to in the way we design, or the way we
Hmm.
support our owner who um, you know who has invested something in us to make sure it was right. So yeah, if that
That's
answers the
great.
question.
Yeah, and I think we have time for about two more questions.
Okay.
Michael asks, can you speak to the challenges of a room that must accommodate both music and spoken word?
Sure. You know, Fundamentally, if we do all the things right, um, and of course the size of the room has an effect on this too, but we can deliver intelligible, and more than intelligible, emotionally impactful speech in a reverberant space.
Hmm.
To do that, we have to make sure that the early reflections live well above the energy that's present in the reverberation. Um, and and so the two are not incompatible if we are careful. Clearly, there are
Right.
places where it's difficult to do that. Clearly, there are places where the church environment for pipe organ is an example where the desire for reverberation is so great, and the ability to put a trained vocal performer in the pulpit is not always the option. Um, we of course lean on microphones and loudspeakers, and we do that with great care and carefulness to deliver energies that doesn't engage the room in the same way that the unamplified sound does. Um, but we've been able to, whether it's the Shed Aquarium, Oceanarium, which of course we used amplification thoughtfully and intentionally there, in a terrible environment because it's a swimming pool. It's a swimming pool for whales. So it's a big swimming pool. Um, and we recognized that the room had a 4 to 5 second reverberation time. But if we delivered not only good focused direct energy, but then followed that with surround sound reflections inserted after the original arrival, we could mask the presence of the reverberation by not just delivering good intelligible sound, but delivering, essentially playing into a virtual small room when you're in a very big room. We were able to make that room very intelligible, maintain directional realism, so you knew who is talking to you from somewhere out in that field, that is the oceanarium, um, and provide intelligible speech in a very reverberant environment. So those two can, you have to be aware of the environment you're working in, but you can stitch those together in a very thoughtful way.
Final question for you, Scott.
Yeah,
What is your favorite performance venue?
yeah, it's a completely unfair question. I will I will acknowledge. So I got into this business because I was a singer, not a very good one. Otherwise, I'd be singing. That's why I'm an acoustician. Um, but the chance to design a new opera house, even one that looks like it's 300 years old, at Rice University, um, was probably so far, the joy of a lifetime. And so I will say that getting the opportunity to listen to great voices in that room remains my favorite experience. And so my own room is my favorite room. Which is a little terrible, but I'm gonna stick with it.
That's excellent. Well, Scott, thank you so much for being with us today and
My
sharing
pleasure.
your experience and your insight. I want to remind our audience that early bird registration is now open for the 2026 Symposium on Education and Engineering, happening July 24th and 25th at Purdue, and focused on turning real-world entertainment industry practice into actionable teaching strategies. That early bird registration ends on March 31st, so get in while you can. Again, another thanks to Scott. Thanks to our audience for being with us today. There's a link in the chat if you're interested in that early bird registration. And have a great weekend, everybody.
Thanks
That
so much, Mercer.
concludes our Fusion First Friday at Fusion Studios broadcast for March, and we'll see you next month.